to talk about just the basics of next generation 911, what it is, how it's different than what existed before, and what we're, why we're doing what we're doing. And there have been a lot of, I attended, I think I've told you all before, I attended my first next generation 911 planning meeting in New Mexico, probably in about 2005, 2007. It was ongoing and being discussed for a very long time before it was implemented anywhere. To this date, it is implemented partially in many places and really not full featured in a lot of places yet, because there's this landline call routing handling thing that still always has to be considered. But you see on this the top graphic I'm showing now, this is the traditional architecture with the E911. And you can see in the middle, there's this lock, that's our black box, our selective router that basically does the 911 call routing, but it's a traditional database system. It's not geospatial. It relies on addressing, and I'll talk about that a little bit more. It relies on connecting central offices that have telephone, exchanges associated with them. It, actually physically connecting all those offices and things like that. So but it's basically, and it's got at the top left, it's got that plug-in right now to get the wireless data in. And a lot of times these can be IP enabled, but they're not routing the 911 call or transmitting all the data on an IP network. But they're considered, that's like the first step to get it enabled for IP communication. And then the next gen architecture, the biggest difference is you'll see the cloud in the middle. It is all IP architecture. And what does that mean? What do you get with that? Well, you get the ability to transmit a lot more data and a lot more kinds of data, and to plug in a lot more applications and solutions to the overall system. It used to be advertised as any call, any device, anytime, or something like that. And I'm going to show you this graphic real quick. And this is just one that was put up by this is the Western Fire Chiefs Association. This is how they used to advertise it. Oh my goodness, look, we're going to get video, we're going to get pictures, we're going to get text messages, we're going to get GIS data. So that is like the user's perspective of how they sell, it is how it's explained and sold to the people on the ground, because the insides of the whole system are not readily apparent to anybody. You don't really see a huge difference when you go to these next gen solutions, when it's a dispatcher sitting in front of that same kind of call taking equipment, the same kind of software and things. There are some, but this is basically, it's just, think about it. IP is bigger hoses, bigger tubes, bigger pipes, right? And, the ability to interconnect a lot more seamlessly by going to the cloud and not having to have all those physical connections. So in essence, that's what it is. It's just the development of technology over time. But I think that from our perspective, because we have to work with the GIS data that fuels the system, and we're doing all this and thinking, why the heck do we have to, and this is Ryan's thing, do not say MSEG to me. It's archaic. But unfortunately, we still have to deal with it. So I'm going to just pull up a little. Any questions? I'm sorry. Did somebody have something? No. Nobody had a question or a comment? I thought I heard something. Okay. I think that this piece right in here, I know that's kind of small. For those of you who have my eyes, we'll make this bigger. Basically, the 911 evolution, that's I think will help explain where we are and why we're there. Started with just providing this 3-digit number that would get you somebody who answered the phone who could help you. That's all it did. Just transmitted your call to it by only having to remember 3 digits. It got you somebody. Now, maybe it got you a 911 center, a dispatch center. Maybe it just got you, they used to have like these fire boards or whatever, where just be some volunteers answering the phone, but it would be somebody to answer the call and you only had to remember 3 numbers. That was the initiation. And that was probably, I don't think that might have even been before the 60s. It was there sometime in the 60s. With phone companies developing more technology like caller ID, They were eventually able to introduce Annie. That's the automatic number information where you would get a callback phone number. So the 911 center would only have your phone number and would be able, when they called, they'd be able to call you back. That was big deal. I don't know if anybody can hear the woodpecker in my house right now, but it's just.
Yeah, we can all hear the woodpecker.
Can you really hear it?
That's a loud woodpecker.
It is. Yeah. I need to go knock on the wall. It's just like, I need to change my location. No, I was supposed to get new siding this winter and this fall, and my contractor had a heart attack. And he's okay, but so I'm pushed back, and it's like, I'm going to send some guys out to patch woodpecker holes. So far, no good. And I'm going to actually move my location. So basically, that basic 911 just got you, basically got the dispatcher the phone number, which is huge. They used to just have a caller. If that call ended, they would never be able to find that person, call that person back. And this is all developed around phone technology, delivering commercial solutions to people who would buy them. And that enabled more progress, for the E911 system. So E911 was basically delivering a physical address. I mean, that's the long and the short of it. Not only did you have the person's callback number, but you had the name on their phone account with the telephone company, with their landline phone, which everybody had back then. And you had a physical address, okay? And that physical address would basically, that information would dip into this MSAG and would extract the emergency service number, which would tell the dispatchers, would give them a 3-digit number, an ESN, to tell them what fire, what law, and what EMS to send to that location. So without having to consult maps, as long as that alley was delivered, the 911 operator would know exactly which fire, law, and EMS to dispatch. Right? So that was huge, big deal, big deal. It also allowed the beginnings of 911 call mapping, auto call mapping at the dispatch centers, because that call was submitted, or it came through with this data string, this ASCII characters, text characters. And from that, that address could be extracted and sent to mapping, and it could be mapped in the GIS. So we were doing our first call mapping, with that technology in the late 90s at SDR. Well, of course, about that time, I always take it to about the mid 90s, which is when I got my first Verizon. Actually, it was not at Verizon back then. It was whatever came before Verizon. And it was a bag phone, right? It was a cell phone that I could take in my car. And once wireless technology was out there, addresses didn't matter because that phone was with you, not stuck to your house. And so instead of trying to figure out, what your address was, it was resolving your coordinate location and sending that coordinate to the 911 center. And that coordinate's pretty darn useless unless you have mapping. So like extracting that address out to actually show where, to geocode that address on a map or to match it to an address point with the landline call. With the cell call, you had to provide mapping at the dispatch to show where that call, where that call plotted. Now, that's where GIS in the 911 world really ramped up, and GIS was required. So that kind of started in the late 90s into the 2000s. So these wireless location studies, I mean, you might all know right now that in landline 911, the wireless location technologies are nowhere as precise as your cell phone when you pin a point to the map and call Uber or whatever. Way more precise because there are a lot of location technologies that you can utilize, just to improve that 911, improve that location, that have only recently become available to 911 through plug-in applications like Rapid SOS, where it's using Bluetooth and wireless in homes and all sorts of things to be able to pinpoint those calls. Wireless started out by what they call triangulation or the network solution, where it would ping distances off of several towers, from your location to resolve your location. And then eventually phones had GPS tech chips in them. And that was, that became the default, but still not as precise because it uses this location resolving system in these 911 networks that are owned by these phone company providers, and they're just not as accurate because there's no money in it. Think about it. Why do companies exist? They exist to make profit, and except for the not-for-profits, which the phone companies are not. And it would be difficult to get a phone company to install a landline phone in your home now. There's just no profit in it. There's no market. And because of that, there's just not a lot of attention paid to developing that technology. Then now we're here with the next generation 911, which basically is moving everything off these traditional or these legacy networks, or these patchwork networks that are IP enabled or whatever, IP once it hits the 911 center versus IP on its way to the 911 center, and moving them on these interconnected networks. So the whole premise is an EZNet. You've heard that term, I'm sure. It's a network of networks. So some states like Oklahoma, I believe, and I know like all in the Southwest, they're all doing this. It just many states have just have chosen one vendor for the entire state to implement that network. And in Missouri, we're going to have networks that are connect together to make a bigger network. So we'll have an AT&T network and an digital network and a Motorola network, et cetera. So it just kind of depends on what happens at the state level. And Missouri's bottom of the barrel with 911, unfortunately, because of our lack of funding in Missouri. Now, I know you're not all in Missouri, fortunately for you, for the 911 capacities. But because Missouri is the only state in the country that doesn't uniformly attach a surcharge or a tax to cell phones, most of the counties, more than half, have implemented sales taxes to support it. And that just introduces another wave of government, and taxation and things, and it just complicates matters a little bit. So basically, that's what's going on with 911. When you dial 911, your call is routed to a 911 center. And if you're calling from a landline phone, they know what your address is. And if you're calling from a wireless phone, they should know where you're standing. Okay? There are two different pieces of wireless 911. One is basic. That means they know what tower picked up your call. The second is, it's called phase one. I'm sorry. And then phase two, your coordinate location of where you are standing is determined by the network and transmitted to the 911 center. That's gotten better and better. Traditionally, it was pretty poor, but it's gotten better and better. But it's even better with next generation 911 and these technologies like Rapid SOS that are able to connect into this big network and pull out that call by geofencing. Basically, if you provide your 911 boundary to Rapid SOS, any 911 call that plots inside that boundary is not just routed to your 911 center by the network, but with Rapid SOS, it pulls it out and resolves it to a greater detail so that you can even tell within a building where you're standing. It doesn't need to have the line of sight with cell towers or anything like that. So that's really the inside basics of what next generation 911 is. Just like your phones and computers have gotten smaller and cheaper and better, it's the same kind of thing happening on the 911 network, but it is because of security and funding issues and a lot of things. 911 technology tends to lag behind where the rest of the country is with technology. This is a huge step forward, in that respect. So let's talk a little bit about GIS. On a traditional network, where's GIS? It's only in the PSAP. PSAP and responders. You don't need it anywhere else. It is an end solution, not a core component. But with next generation 911, the GIS is actually integral for routing the call. Before the call is sent to a 911 center, it has to be plotted. And then when you plot a 911 call in this, they're called the core services. That's the GIS interior component of a system. You open my map real quick. This is Iron County, but I just kind of, you've seen these before. I just opened the PSAP attribute table, and you see these GUIDs everywhere in these. You probably our programs our tools just generate these. This is a placeholder. When InDigital takes Iron County live, they will assign it a name and the rest of this IP address. But this is actually the component when that call pings and that purple boundary, which is this PSAP, this is what routes the call. That little URI or URL or whatever they call it in this aspect. But that is what is going to say, hey, that call has to go to Iron County. And it has a PSAP ID and all those different things. And so that's why all these things exist here. But they also, and that's why your topology has to be good, because if this happened to map in a gap between two 911 centers, it wouldn't route anywhere automatically. If the PSAP boundaries were on top of each other, they overlap by a few feet, and that call happened to plot in that area, it would plot within two boundaries, and it would have to have rules built into that system as to, okay, what happens when we get two routing codes? Which one do we use? Which one takes precedence over the other? Or else it goes back to default routing, and often that's the least busiest call station on the network. Wouldn't have to be in your own county, it would normally be in your own state, but it could be far away from where that call should have gone. So, but that's why that, the topology matters so much. Now, that's all great for the 90% of the 911 calls that come in that are wireless, but we still have to deal with those legacy calls on the wireline system, right? Landline calls. And that's why we have to keep the MSAG up, because until they understand completely how, and they do, but it's the last thing considered is moving those landline calls to be able to route. Well, if they can't route by coordinates because they don't have coordinates associated with them, could they? Absolutely. That would mean changing traditional telephone company database architecture, though. They have to route by address. And to route by address, what do they have to do? They have to match to an address point or a center line. So if they don't match to an address point, they have to match to a center line. And the center lines and address points have these routing codes embedded in them too. But because they're matching to center lines and address points, that's why the addressing components have to be so good. Why we can't have duplicate addresses, why we can't have overlapping address ranges. Everything has to be unique. So that's it in a nutshell. Was that good for 19 minutes, Julie, or not?
Yay.
Great.
Have I convinced everybody how important the MSEG is yet? No, I probably haven't. But you see what I'm saying, that there's this legacy component still have to come in, and the only reason they leave those legacy fields, your traditional 911 parsing, in the GIS to accommodate programs and CAD programs and call mapping that haven't advanced all the way up to the new parsing, and also so that you can compare those to the MSAG, which have the standard abbreviations and things like that still. So I think that in my lifetime, and certainly my career, I will not see the MSAG go away. I'm sorry to say. I think many of you, if you stuck in this career in this direction, would see that happen. Anyway, questions? Clear as mud? Why do we parse everything out into 8 different?
I have a question.
Yes.
Because I would like to extend this call a little bit. Not really.
Thank you, Glenn.
I know. I wanted everybody to know, I'm the kid that said, you didn't assign homework. Actually, that was never me. What is the part of the next gen 911 system? Because this is like one of those other selling points that where some other PSAP could pick up your PSAP in the event of a natural disaster of some sort, or whatever.
Because everything is code-based and cloud-based, and not individual network lines running, underground or whatever between 911 centers and station, and central offices, phone switches, and things like that. If it's in the cloud, you can connect anything with permissions, right? And so you can do rules. Yeah.
So like with Carroll County, we share or want to share information, say with Sheraton.
Right.
So basically Sheraton has a code, Carroll has a code, and basically what they do is put the code in, okay, and make all the calls directed by the Sheridan County code. Is that right? Is that like
Yes.
if there's a
Mhm.
failure? Oh, wow,
And
okay.
it can go way deeper than that, Elizabeth. It can say,
Oh,
hey,
yeah.
our traffic is so high, let's send calls from these two ESNs somewhere else.
Oh, wow.
Yeah,
Man,
it
there's
can
a
go
lot
really,
of,
really deep, or these two responder polygons or whatever. Mhm.
that's a lot
And
of
it can be,
programming, isn't it? That's a
yeah,
lot of
and they're
data
it's
entry.
rules.
Wow.
It's programming and rules.
Oh, wow.
It can say, we are a call center that only takes calls till midnight. So from midnight to 8, they go
Oh,
somewhere else. I mean, it can be time
wow.
related too.
Oh,
So
my
they can
gosh.
essentially assign codes to whatever PSAP they
Yep.
want, or
As long as you're on the same
Wow.
as
on the
needed.
same network. So yeah.
Right.
And have whatever parameters that, that they want to follow. Oh, wow, that's amazing.
And that's why the data is so standardized with all that road name parsing, because the idea here and no abbreviations and all that make
Yeah.
everybody crazy. It's because if all of a sudden you had some sort of outage and everything north of the river was down and your calls were being routed down to like Pettis County or something, and
They-
people wouldn't know where, they want to
Yeah.
make it, it has to be very clear because they're not going to be familiar with your data.
Right.
So
It needs to
they
look the
want to be
same.
very, very clear as to what that location is.
Yeah, that's important. Wow.
That's the premise behind it. You have to kind
Yeah.
of think it's annoying for all of us who have to like scour
Yeah.
data for abbreviations and parsing and all that, but it's just, if you had like old business highway something or other,
Uh-huh.
and if you parse all those pieces out and you get a call from old business route, you can still map it because it's like that hierarchy of, there are no straight matches, but here, this is a 90%
Oh.
match of all the components. Yeah.
Interesting.
Yeah. So it's
Huh.
but here on our end, we're dealing with the end of it all, and we're
Right.
kind of trying to plug it in backwards. And so kind of knowing
Yeah.
why that is, it helps me. I think it's still annoying. The MSEGs especially are very annoying. And the MSEGs are mostly annoying because not everybody, but many 911 centers have really been lax on maintaining
Yeah.
them because it's so few people get landline phones. And
Right.
if you have a new development, a new subdivision, and there are 5 or 6 streets in it, maybe one person gets a phone or 6, they may all be on one street. There may never be a need, like a demonstrated need to get the rest of that data in the database. So
Uh-huh.
that's why that is. It's, I don't know that that's a good thing. It's just the reality of what we deal with.
Right.
So,
Wow.
okay. We used to call these lunch and learns. Remember, Glenn, when we had
Yep.
these back in the day? Lunch
Yep.
and learn.
Awesome.
We'd provide lunch and everybody would come in and learn. Back before we had Teams.
Say, where's lunch?
I want
Where's
my
the
lunch.
That's right. Anyway, so everybody, you're going to get